for C, what we have is, let's first talk about the domain. So on C, because we don't see any square roots or fourth roots or sixth roots, and I don't see an x in the denominator of a fraction, that means I have no restrictions. So my domain will be everything. So from negative infinity to infinity. That's the domain of my original function, which means it's the range of my inverse. The other thing about this particular graph is that it is cubed. So one of the things we're going to learn later is that this also has a range of everything. There's no restrictions on the cubes. So that is the domain of my inverse. So we got that out of the way, because on the test it's going to ask you, and on the homework it's going to ask you for the domain and range of both the original function and the inverse, or possibly just the inverse. So domain of the original becomes the range of the inverse, the range of the original becomes the domain of the inverse. So then y is equal to negative x cubed plus 2. So I replace f of x with y. I'm going to solve for y by doing y minus 2 is equal to negative x cubed. I'm going to multiply, or you can consider and divide it by negative 1, so it's negative y plus 2 is equal to x cubed. Now I'm just going to take the cube root of both sides, and the cube root of negative y plus 2 is going to be equal to x, and then I just do that replacement, f inverse of x, and it is at this moment when I do this notation when domains become ranges and ranges become domains. So the cube root of negative x plus 2. And then I should check this both ways. So what I should check is I should check if f inverse of x, f of x, is equal to x, and f of f inverse of x is equal to f of x. I should check that both ways. Now, and I will in a minute. When I go to graph this, what this graph is the cubed function. Now that's a parent function. It's a terrible, terrible graph. So the cubed function is one of the parent functions or toolkit of functions. We have the negative here, means that it's going to be reflected. And then this 2 means I'm going to be moved up 2. So I'm going to be moved up from the origin to 0, 2. And then I'm going to go through these points. So it's going to look something like this. So that's what my original function looks like. Now my inverse function, if I would have gone through the point, the new moved function would have gone through the point 0, 2, then it'll go through, the inverse function will go through 2, 0. If this one would have gone through negative 1, 3, then this should go through 3, negative 1. And so this is what the function should look like, something like that. So that's what the inverse function should look like on the graph. Any questions on that part of it? Okay, and I recall that I did this one yesterday as well, but it's not bad to start out with it. So go ahead and do D. So we're looking for the inverse function of D, and be sure that you state your domain and range and graph the original and the inverse. So I'll give you a couple of minutes to do that. Okay, so let's talk about the domain of the original function. Now remember, whenever I have a radical and the index, which when I'm talking about index, just as a reminder, the index is this power that's right there. That is a power of 2 if it's missing, so it's a square root. And the domain, yes, the domain in this one is going to be from negative infinity to 5, because the way that I find my domain is I put the value that's underneath the radical, which is 5 minus x, set it equal to greater than or equal to 0, and then so 5 is greater than or equal to x. All I did was move the x over. So I know that my domain of my original function must go from negative infinity to 5. And that tells me that right out of the gate, I have found the range of my inverse function. So let's go ahead and solve for x. So y is equal to the square root of 5 minus x. And then I need to get rid of the square root. So that would have been the last thing I would have done in the order of operations. So it's the first thing that I undo. So I'm going to square both sides. And I get 5 minus x. And then I'm going to go ahead and move the 5 to the other side. So I get y squared minus 5 is equal to negative x. And I need that to be a positive x. So what I'm going to do is I'm going to divide or multiply, depends on how you look at it, a negative number. So I have negative y squared minus, or becomes a plus 5 is equal to x. So my function, my inverse function then, is going to be negative x squared plus 5. Let's go ahead and graph my original function. So my original function is the square root, and what this negative does is it actually does a reflection across the y-axis, and if I put it in the right form, and what I mean by right form, so I'm going to just write this down here. Remember, I want g of x to equal a f of b of x minus c plus d. So what I need to do then to make it in the correct form is I need to put x first, and it needs to be positive. So this is just a nice refresher for the transformations of graphs. And so for my f of x is equal to the square root of 5 minus x, this is equal to the square root of negative x plus 5, which is equal to the square root of negative x minus 5. And all I did there was put it in the right form. So is I wanted to make sure that my x is positive and first. So all I did was switch positions of these two. So instead of doing 5 minus x, it is negative x plus 5. And then I want the x to have a leading coefficient that's positive. So I factored out a negative 1, which then changes the sign on the x, and it also changes the sign on that 5, so it becomes negative 5. Now, that tells me that my graph is reflected over the y-axis as moved to the right 5. So 1, 2, 3, 4, 5. So this is what it's going to look like. It's going to look something like that. So that's my original function. So that's f of x. And then what I'm going to do is I'm going to graph my inverse function by not necessarily looking at my inverse function here. Because if I look at my inverse function here, this is a quadratic and it is not restricted. However, my domain of my original function, which is the range of my new function, of my inverse function, is going to be from negative infinity to 5. Okay, cool. But I can tell on my graph right here. My graph tells me that my domain of my original function, or my range of my original function, is from 0 to infinity. It's actually going up this entire time. So here's the lowest y value, and then I'm looking for y values, and you can see that this has an arrow going up forever. So I start at 0 and go up. That tells me that is the domain of my inverse. So my quadratic is, even though it's a quadratic, and this negative, my quadratic tells me I am reflected across the x-axis, and I moved up 5. This tells me that I'm only going to take part of the parabolic shape. I'm not going to take the entire parabola. So my inverse function will look like this. 1, 2, 3, 4, 5. It's going to look something like this. So that's what my inverse function would look like. Now I'm going to pause, and I want you to ask all kinds of questions. We're going to check both ways in a minute to confirm that the inverses work, but I just want to stop here. I've gave you a lot of information on one problem, so I want to stop here and ask you what kind of questions you have for me. The question is it always going to be a rotation of 90 degrees? Well, what it really is we have this y equals x line, and everything's going to be reflected over the line y equals x. So that's how come this point, which is on my inverse, relates to this point on my original function. Just like this point, which is on my original function, will become this point on my inverse function. So it's not necessarily a rotation of 90 degrees, it's a reflection over the line y equals x. Check, and then I'm going to write one that I want you all to do because it's going to be similar to your homework. So I'm going to come over here, I am going to check, so I need to do the check. So I'm checking to see if f composed with its inverse is equal to x, so I'll do that one first. So f of what I think the inverse is negative x squared plus 5. I'm going to put that in the original function, so the square root of 5 minus negative x squared plus 5, which is equal to the square root of 5 plus x squared minus 5. You can see my 5's will cancel, leaving me the square root of x squared, which is just x. So that does check that way. Now I have to confirm that f inverse composed with its original function is equal to x. So f inverse of square root of 5 minus x is equal to, so in my, what I think the composition is, I'm going to put that in there, so it is negative the square root of 5 minus x, the quantity squared, plus 5. So this is equal to, when you square a square root, you're just going to get the value underneath the radicand. So then I'm going to distribute the negative through, so negative 5 plus x plus 5, and you can see that my 5's will cancel, leaving me just x. So I have indeed found the inverse. What I would recommend when you are taking the test, because there is plenty of time to confirm that that is the inverse, and you are going to have to show your work on the test by submitting that into the Dropbox, is take the time to check. If it doesn't check, then you know you haven't really found the inverse, and so then it'll be marked wrong, obviously, in the test. So take the time to check the inverse just to make sure that you have it, and then it will save you so much heartache later because you can take the time to check. Is there any questions on this before I have you all work on one that's going to be similar to something out of the homework? Okay, so what we're going to do is we're going to go ahead and do one that's going to be like the homework. Now I'm just going to come up here so I can use these spaces. So I'm going to pull one off similar to the homework. And let's start with something like this. Let's start with the original function f of x is equal to 5x over x minus 2. So that's the original function. I'd like you all to take the time to see if you can find the inverse. Get as far as you can get. If you've got an answer, go ahead and write it in. If you get stuck, that's okay too. This is the opportunity for you to try doing something that's similar to the homework before you get to the homework. And also, I'm here to help support you. So go ahead and try that one, and we'll come back and talk about that in about 2 minutes, 2 or 3 minutes. So with the first one, what we're going to do, like before, is I'm going to do y is equal to, I should talk about the domain of my original function. The domain of my original function is that it can be any number except for 2. So negative infinity to 2, union between 2 to infinity. Now we know that this automatically gives us the range of my inverse. So y is equal to 5x over x minus 2. Now I'm going to go ahead and multiply both sides by x minus 2. And so I have y x minus 2 is equal to 5x. I'm going to distribute that y through, and so I get xy minus 2y is equal to 5x. Anything that has an x attached to it will go to one side. Anything without an x attached to it will move to the other side of the equal sign. And so I'm going to bring the 5x to the left. I'm going to bring that negative 2y to the right. So I have xy minus 5x is equal to 2y. And if you did it the other way, that's totally fine. It's totally fine. So on the left-hand side, I'm going to factor out an x, leaving me y minus 5. And on the other side, I still have the 2y. I'm going to just divide both sides by the y minus 5. So I've got x is equal to 2y divided by y minus 5. And it is at this moment my domains become ranges, my ranges become domains, by f inverse of x is equal to 2x over x minus 5. Now, I can tell you what the domain of my inverse is, which will give me my range of my original function. My domain is everything except for 5. So negative infinity to 5, union between 5 to infinity. So that is going to be the domain of my inverse, which gives me the range of my original function. So sometimes I may not know the range of my original function until I've actually done the inverse to find where it has a restriction. Is there any questions on that first one? So I want to make sure that we're all on the same page and that we can be successful on these on the homework. Is there any question on these? I'm going to go ahead and set this one. So again, I replace f of x with y. So y is equal to 2x plus 5 over 3x plus 1. I'm going to multiply both sides by the 3x plus 1. So I have y 3x plus 1 is equal to 2x plus 5. Don't forget to distribute that y through. And so I have 3xy plus y is equal to 2x plus 5. As before, whenever I have x's to one side, non-x's to the other, so I'm going to bring that 2x to the left and the y to the right. So 3xy minus 2x is equal to 5 minus y. On the left-hand side, I'm going to go ahead and factor out an x. So I'm factoring out an x, giving me 3y minus 2 is equal to 5 minus y. I'm going to divide both sides by 3y minus 2, and so I have x is equal to 5 minus y divided by 3y minus 2. And then I'm going to replace my y's with x's and my x with f of x inverse. So 5 minus x over 3x minus 2. Now let's go back up here and talk about the domain of my original function. Now my domain, what I do again is I set the denominator. 3x minus 1 cannot equal 0. X cannot equal, it's plus 1. X cannot equal 1/3, negative 1/3. So the domain of my original function is negative infinity to negative 1/3, union between negative 1/3 to infinity. This is the range of my inverse. And then to find the range of my original function, I set that not equal to 0. So 3x minus 2 cannot equal 0. So x cannot equal 2/3. So the range of my original function then is going to be from negative infinity to 2/3, union to 2/3 to infinity, and that is the domain of my inverse function. Now I should be checking these both ways just to confirm it works. Does anyone have any questions whatsoever on these two examples? Anything at all? If I'm asked to find the answers with the table of values, so if I'm asked to, I'm going to do some that are not here. If I'm asked to find f of 0, then I'm asked to find 0 and my output is 8. But if I'm asked to find f inverse of, say, 5, then what I do now is I'm going to go along my f of x, I'm going to go along my outputs until I see 5. Once I have 5, then the answer is 6. So then this is equal to 6. This is similar to saying f of x is equal to 5. Find the x that gives me 5. So those are equivalent. So if I'm asked for over here, which I'm going to have you all do, if I'm asked for f of 1, then I just find 1 and find the output. But if I'm asked for f inverse of 9, then I'm going to go in my f of x row to find 9 so I can figure out what x produced that 9 as the answer. So I'm going to give you a couple of minutes to go ahead and do these by looking at the chart. Confirm some answers. So if I am asked to find f of 1, I'm going to go here on my x's and I find 1. My output is 0. So my answer to the first one is 0. If I'm asked to find f inverse of 9, I'm going to go across this row, find the 9, and 8 was the value that produced 9. So this is equal to 8. And then I'm going to find f of 3. So again, I'm going to go along the x row. So if I'm looking for 3, 4 comes out. And then my last one here, I'm looking for f inverse of 3. So I'm going to go along my f of x row and look for 3. So 3 was the output, 7 was the input. So the answer to the last one is 7. Is there any questions on that? Okay, cool. So let's take a look at our last example, and then we will be able to get into chapter 2 today. So a car travels at a constant speed of 50 miles per hour. The distance the car travels in miles is a function of time and is given by this function. d of t is equal to 50t. Find the inverse function by expressing the time traveled in terms of the distance traveled. Call this function t of d. And then find t of 1800 and find its meaning. So go ahead and find the inverse of this particular function. Now, when you are doing this particular function, what you're going to do is, instead of replacing d of t with y, you're just going to replace d of t with d. So d equals 50t. So go ahead and find the inverse on that, and then we'll talk about what the meaning of that is. Okay, so just pretty straightforward here is if I start out with d is equal to 50t, I'm just going to divide 50 by both sides. So d is equal to 50 times t. And unlike before where I was asked to do d inverse, what they're asking us on this one is to label it t of d. So the function is the time with respect to the distance. And so my variable this time is the distance. So it's the distance divided by 50. And so if I'm asked to find t of 180, that means I'm asked to do 180 divided by 50, which is 3.6. And so what the 3.6 represents is the hours it's going to take to drive the 180 miles when we're driving at 50 miles per hour. And they're probably going to be in front of me, and they're probably going to be on my way to work the entire 44 miles, 50 miles an hour in a 70, because that's the way it is. Okay, is there any questions on this before we start into chapter 2? Anything at all?